Hello guys, good evening. Let's start. Welcome to all of you into the 10th live interactive session for the course Artificial Intelligence and Machine Learning in Materials Engineering, which is being instructed by the Professor Krishanu Vishwas from the MSc Department IIT Kanpur. Uh, this course is available on the NPTEL platform, and I'm the PMRF TA for this course, which is conducting this live interactive session. So in the previous live interactive session, we have already discussed about the how the machine learning helps the materials engineers to design the materials and how they determine the property. Am I audible now? Okay. Okay, in the last few sessions, we have discussed how the machine learning helps materials engineers to design the functional material and in a different ways, like how you can get the image segmentation thing, how the NLP can help us to get the structured data from the unstructured data, and how you can predict the phases of the material, like how you can classify that, and how you can predict the any numerical value from the model, which is trained by using the data. So now, in the previous session, we have also looked for the some uh, hands-on tutorials, like how they do these things. So in the previous two sessions, we are learned about the how you can load the data in the different ways, how you can do the things like how you can see the data, how you can describe the data, and how you can clean your data before going for the model training. So that was done on the some things which we have prepared synthetically. It means we have prepared synthetic data and do the all the things and describe you all the things. So now we are going to take a data, like I'm going to share some websites to you where you can get the data related to the material science. So let's start. Okay. So there is a repository, open repository, which is called the Matminer. There are some other repositories also, but this repository have the some data set, and you can use those data set. And beside these, having the data sets, uh, this repository is also a library thing. Like you can use this library to featurize your data. So this is the documentation of this thing, Matminer. So you can go for this documentation and you can get how to install this, how you can use this, which kind of data these have. So I will encourage you to go for this documentation, which will help you. So now uh, I will show you how you can use that. And there is a something which is called the Pymatgen. What's the Pymatgen? Pymatgen is also a library which is used to like convert any composition into its properties. Like just suppose if you give a composition to the give a composition to the computer, it will not recognize what like this composition. Like just suppose you have a strontium titanate, SrTiO3. But for the machine, there are some alphabets which are in the uppercase and the lowercase, and there are some numbers. So it will treat it as a string. So to give uh, uh, to recognize what elements are there, how much ratio are they have in that composition, that is done by the library which is called a Pymatgen. You can maybe there are the more libraries like this, but in this work we are going to perform our work by using the Pymatgen. Instead, you can look for the literature, and there are the various kind of libraries for each thing. Like there are the different repositories also for the data set, like Citrination. Uh, there is also a repository. Here you can get the different data about the material science. I think they have recently changed their interface, but here are some data points also. Okay, got it. I think I misspelled this thing, but there is a kind of website which is called a site Citrin. From there, you can get the data like which is related to the material science. So we will start. We will load the data from the Matminer, and then we try to decode the composition by using the Pymatgen, and then we featurize our composition in terms of by using the Matminer. So we will look what is the Matminer, and which kind of things we can do with that. So first of all, we have to install the libraries uh, with a particular version, because the Matminer work for the special version of the pandas and the SciPy. So you have to be precautious about the version of the libraries. Otherwise, you can't do your work. Please open the link which I have shared in to the chat box. Please open this code share. So So this is a code where you are installing the libraries with the special version like Pandas 2.2.2 version and the SkyPy for the 1.10.1 version and the Matplotlib, Cband, Skitland, Matminer and the Pymatgen. And this the for the restart the kernel because after the installing the libraries, the thing you have to do to restart your kernel. So that's why there is a thing. So this is for the exit the kernel, means the restart the kernel. Then you have to import the necessary libraries like pandas as PD, numpy as np, matplotlib as a plt, c1 as sns, and the sklearn model selection. Import train test split because you have to split your data in the train test cross validation score to evaluate the cross validation of your model. And this is a grid search CV, which is the cross validation in the grid search. Like if you are optimizing your the hyper parameters, so for that purpose it will be used. And this is the scalar pre-processing standard scalar, which is used to standardize your data. And you can also use the min-max scalar also. And there is a thing scale and ensemble import the random forest classifier. Here I just import the random forest classifier to train the model. In the upcoming cells we will import the other classifiers also. And there is a feature selection thing which is import RFE. RFE is like recursive feature elimination. Like if when we discussed about the feature selection in the last session, we discussed about the different ways how to do that. Yeah, because and in some paper, in some work session, we have discussed about the stacking fault analogy. They have used the wrapper method. So this recursive feature elimination will be used in that work also. And there is a thing SQL and matrices for the classification you have to do for the accuracy score classification report and the confusion matrix. So you can you have to install import these things. And there is a Matminer data set import load data set because I told you the Matminer has the different data sets. So for look for the data sets you have to import this thing load data set. And from the Matminer featureizer composition, I import element properties because I'm only going for the element properties, but there is a different kind of property in the Matminer. You can also use those things also. Data descriptor tools. Here is a different thing like get the Pymatgen descriptor. So there are the different kind of descriptor like the composition descriptor, structural descriptors, band structure descriptors, mechanical properties, thermal conductivity models. So these kind of properties you can load and you can featurize your composition according to that. Like here, I am just using the element properties of the composition. Then there is a pymatgen.core import the composition. As I told earlier, you have to uh, make your composition in such a thing so your model can understand that. So for that purpose, we will use this thing. So now let's start how you can load your data from the. I think I have not shared this. Please go in the code share and copy these libraries and paste in your notebook. Okay. Now, from the Matminer.dataset, import the get available datasets. Like, first of all, I am doing what the datasets are available here. Okay. So, if you run this from the Matminer dataset, first I use this code to get the available datasets. Then I print available dataset as the get available data. Like, what kind of datasets are here? Then there is a, I print those values and run this. So you will get kind of data set like a ball strap MP. It's a this MP is a means the materials project. Materials project is also a uh, website from where you can get the data about different thing like especially you can get the structural data and the electronic data also from here. I think this is getting some time. So this is the effective mass of the thermoelectric properties of sorry, effective mass and the thermoelectric properties of the 8,924 compounds in the METIS project database that have the calculated by the Bootstrap software package. Run on the GGA PB, which is a DFT based technique, and the GGAU. Uh, so this is the computational data which have the effective mass and the some thermoelectric properties of these compounds by using the DFT. And this is the other one is the BR goes super hard training. And this data set have the 2,574 materials for the training regression to predict the shear and the bulk modulus. So this is the data for about the composition and its shear and the bulk modulus. And there is a another thing, this is data set about the perovskite, which have the ABX3 combination, and here is also the DFT based data set about the band edge position and the heat of formation. And there is a thermal conductivity data. So these are the different kind of data which these Matminer have. So here you can see there are the in just one name, there are the data, Bootstrap Trap, Matters Project, BR Go, Super Hard Training, Castelli, perovskite, citrine, citrine thermal conductivity, dielectric constant, double perovskite gap. So this kind of data you have, and this data you can use for your purpose. How you can use this? Let me explain. Uh, please, please run this your code in your notebook. Now, as you get this value, this output. So in the among all the data, like this the short name, you have to copy that this name which data you want. Just suppose I'm going to show you the example about this case perovskites. So I just copy this name, and now I am importing this data. Data is equal to load data set. Then name of the uh, data which you want to load here. Then I use this data dot head just to see how my data look like. Besides this, you can also use any data. You are not just restricted, just you are going for the Castelli perovskite. You can load this BR Ghost, super harder training, set train thermal conductivity, dielectric constant, whichever you want. Now, if you want to see the data like data dot head, so here you can see there is a these columns like Fermi level, Fermi width, E form, gap is direct or not direct, structure, structure information, MUB, that means effective mass, I think, and there is the formula of the composition, and there is the valence band maxima, this is the conduction band minima, this is the gap GLLSC. So this is the thing which are here in the data set. You can also look for the more things which are here, like what is the shape of the data, what is the name of the columns here, so data
Sir,
dot shape. Sorry.
sir, the data is called load underscore dataset. I have got something else, something like I have got links fetching castle provides
Can you paste your error into the chat box?
not error, sir, but it's like a link. It is a form in a link, sir.
So many links. Can you please paste? Otherwise, I'm not able to understand. Like,
Okay, sir.
otherwise, you can share your screen also. Your output should be the same as I got. Okay, it is take some time actually installing the data. Actually, I have did the data earlier. That's why it is not taking the time for me. Is a bar. I think that is running from. So you can see here is the something is a okay. Your data is loaded. Here you can see the all the files is loaded. Maybe before that there is a some bar which is going to be filled from the like 0 to 100. Now it is loaded. Please run the data dot head. I think you will get the results. Data dot head. Now the bracket open and closed. Now run this.
Okay,
No, don't copy and paste this thing. Just bracket.
okay.
Now control shift enter. So you can see your data is have loaded.
Thank you, sir.
Okay. Okay. My sharing stopped. Okay. Now you have loaded your data. Like you have see how your data look like. So now, if I want to see what is the shape of the data, you can also sorry shape don't have like there is a 10 columns and 18,928 points like in the rows in the data. Now, if you want to see the how your data is statistically look like how many, what is the for every column, how many, what is the mean of that column, what is the range of that column, and what is the other things like 25 percentile, 50 percentile median, and what is the 75 percentile of the data. So you can look like this. There is a code which is called a data.describe. So it will give you the information about your data. Then as you got your data, then first of all, what thing you have to do? You have to do the cleaning of your data. Like you have to see, is there any null points? Is there any duplicate point? How your data look like? So for that purpose, there is a code like if you want to see how many null values are there in particular column. So for that purpose, you can run this code like data dot is null, and there is a something like how many null in a particular column are. So if you see, there is a no null value in any column, like in Fermi level, there is a no NaN value. In the Fermi width, there is a no NaN value. E form, there is a no. So in any column, there is a no NaN value. So if there was some NaN value, so for that purpose, you can remove those rows in which NaN values are present. For that purpose, there is a code data dot drop NA. It means if any row that have any missing data, that row is completely deleted from the data. So this is the code for that thing. In the previous session, we also discussed about the very other ways how you can treat these NaN values. Like you can fill it with the some mean values of the data, some mode value of the data, some median of the data, and as well as you can also with the previous one like your data is missing in this row, and the upper row have the some value, so it will be filled with the upper rows value. So those are the ways you can treat the NaN values. Now, if I want to see what is the shape of the my data, so this is the same because there is a no NaN value. So I have not dropped anything. Now, just suppose, okay, visualization we will take out in the last. Uh, like just suppose you want to featurize your data. So as in the earlier session, we have discussed about how you can do featureization of your data manually. Like you are taking the average, elemental average from the composition and use that and multiply it with the properties and get the average properties and the deviation of the properties as you see in the earlier works. So this is the thing you can also do, which is about the elemental properties from the Matminer, and you can also convert the composition into the like sorry. Uh, but first of all, you have to convert the composition into something which your machine can understand. So for that purpose, we have make a column data composition is equal to data formula. If you see in your data, there is a column which is formula which what is showing the name, the chemical composition, chemical formula. So I'm going to convert this chemical formula into the composition. What is this composition? This composition is not a name, it is a command. If you see the install import part, here I have a import Pymatgen.core import composition. This is that composition. Okay. So I'm going to apply this composition onto the column formula of the data, and what it will give, it will give the data. There is a new column which is named as a composition. You can also give any name. I just give the name the composition. And featurizer is equal to element property dot from preset Magpie. Magpie is a thing which is do the featurization into the Matminer. So that's why we have used this, and elemental property we have earlier imported. And now after this thing, like I import this value featurizer, and I convert my formula column into the composition. Now data featurization new columns will be appeared is equal to featurizer dot. Featurizer means which I have installed earlier. Featurizer feature data frame. What is the feature data? Featurized data frame data, and in the data what column should be featurized composition. So this is the how this code is written, and now you can copy this and paste in your notebook. Please copy this and run in your notebook. Maybe it will take some time because there is a 18,000 rows. So surely it will take time. Now you can see here the 100% featureization have been done. So all of you are getting the same thing, or is it done for all of you, or please inform anyway. When it is done for you, please drop a message into the chat box, or you can unmute yourself and give the answer. Is it completed? Okay. Now, just you have done the visualization of your data. Now, if you want to see like how your data look like now, I have saved this data as a data underscore featurized here. Okay. Now, if I want to see how my data look like, so there is a thing. I will use the this head command for that. So now you can see there is a some new column like Magpie data range, Magpie data mean, Magpie data average deviation, Magpie data mode, Magpie data minimum. So these are the new columns which have created by using these elemental property thing. So now if you want to see how your data like how what is the shape of your data, now you can see there is a uh, same number of rows like 18,928, and if you see the columns had increased from 10 to 143. So there is a new column which is about 133 new columns in the data. So what is this column? You can also look like you can save this data. I just suppose data to CSV. So now you can see here the data is saved. How much time it will take? Okay. Now this. Okay. Now you can see here. This is the index of the row, and this is the Fermi level value. This is the Fermi width. This is the E form. This is the gap is direct or not direct. So here is the structure, information about the structure of the material, and this is the mu b, maybe I think mobility of the data, and this is the formula. What is your composition? This is the valence band maxima. This is the conduction band minima. This is the gap, and can I go? Okay. Now you can see here the Magpie data minimum man-leave number, Magpie data maximum man-leave number, Magpie range, Magpie mean, and Magpie average deviation. So there is a many statistical tools are used for the same kind of thing. Like if you are going for the man-leave number, so there is a minimum, maximum, range. Then there is a mean. Then there is a average deviation. Then there is a uh, then there is a mode. So these are the different uh, statistical things which are used for a single property. So this is how the Magpie featurize the data. So it is the average all the properties for the composition. It will find the maximum value. It find the minimum value. It find the mean. It find the average mean deviation. It find the it find the mode of the thing. So this is the how it featurize the data. Now I have get the lots of the features, but all the features I am not going to incorporate because this is the very large number of the features. So our models can be slow, and there are the many features which can be non-relevant to our output property. So first of all, I have to think what is my output property. Like just suppose here in the original data, there is a this column, Fermi level, Fermi weight, E form, gap is direct. Just suppose I am going to predict this data have the direct band gap and the indirect band gap. Okay. Now just suppose I want to find this column in this composition have direct band gap and or indirect band gap. So I have composition, and this gap is direct or non-direct. So how can I find out this thing? So I will. So first of all, how my problem look like? So I have to classify the composition in such a way like what is a direct band gap and what is the indirect band gap. So I have which model I have to go for the classification models. Okay. So now I have featurized my data. So I have to do some feature engineering. Like I have to find out like what features are most important to me, which features I want to use for my model, what features I have to drop. So how can I do that? So in the last session, if anyone of you have attended, in the last session we have discussed there is a three techniques. Just suppose there is a one technique which is like the filter. Like I have just filter some on the basis of some numerical value. Like just suppose we have discussed about the PCC, Pearson correlation factor, correlation coefficient. In that we have discussed like if your in fact, your features are correlated to each other, very correlate. So they will give pass the same information. So you can remove one of them. Okay. Then there is a something which we have discussed about the covariance. So covariance coefficient. So you can get the values of the covariation coefficient for each descriptor to the output property. So you can see how your output property will change according to the input property. Like just suppose your data is not moving so much, like uh, not affected so much by you by changing your input property. So there is no meaning to have that property in your input property. So you can remove those. So and after that, we also discuss about something which is called the wrapper. After the filter, there is a wrapper method. In the wrapper method, there is a thing you can uh, make a uh, sorry. In that you can make a cyclic loop where you can check which properties are going to the your positive feedback and which property is not going give to your the negative feedback on your output property, and then you can also in the post you can do that maybe I have that just wait, I think I have that slide. Okay. So if you see, which is we talk about the filter method, in which you will go for the any number and see which descriptor will be best for you, and you can make a subset and train your model according to that. Then there is a wrapper method. What this wrapper method do? It will initially it start from the zero features, like it is not going with any feature, and it train to the model, and it increase the feature values. Like just suppose first of all it take a feature A, it train the model and it get the some accuracy value, then it take the some other feature b feature, then it do the same, and it see your accuracy is increased or not. If your accuracy increased, it is going to be give a positive feedback, and it included that feature in your input data. But just suppose it is not going to increase anything, so it is not going to take that feature into your final subset. Same, this is the forward thing. Now, in the reverse thing, just suppose your forward model give you to the five features. Just suppose A, B, C, D, E. Now, how these elimination, then it is going for the forward elimination, backward elimination. Sorry, in the backward elimination, what it do? Like you just suppose you have the five feature, so it is going to remove one feature and train the model and see it is change any accuracy or not. If it is not going to change any accuracy after removing the feature, so that feature is going to be eliminated because it is not going to contribute anything. So this is the way how this wrapper method work. And there is a one embedded method which is some complex method called comparable to the this depth method. What it do here? It create a subset. Like just suppose you have a five features, so it is make a do the some permutation combination, and it make a combination of the different subset. Like there is a subset which have the one feature, then there is a which have the two feature, then there is a three feature, then there is a four feature, and there is a some five feature. Now, all the features subset having, sorry, your model is going to be trained all the features, all the subsets, and then it will give you the which subset is going to be give you the highest accuracy. Okay, so this is the way. So now we are applying these two methods, filter method and the second is the wrapper method in our this work. Because I have a large amount of the features, like there is a 143 features. So I'm not going to incorporate that in training of my model because it will take a long time. So now, maybe now the course here is going to work or not. Okay, great. Okay, all of you have done with this saving the data, featureize data. Now, just suppose you want to see what is the columns here, so you can write this command like your data frame name dot columns. And now, just suppose what is your data set in the previous look like before uh, this featureization. क्या बोला ये? Sorry guys, maybe this board share is creating problem. That's why I'm going to use any alternate of that. And I think this is now working. Data the underscore featureize dot columns. Now, you have to decide what is your X and what is your Y. So as I talked earlier, we are going to predict what is this band gap. Like this is the direct band gap. This is the this material have the indirect band gap. So we will go for that. So for that purpose, I have to decide what would be the my X. It means what would be the input properties and what would be the output property. So if you see here, these are features which I have done with the Matminer, and these columns are the in the previous data, like this composition created by the uh, uh, sorry Pymatgen, and all of the things was in the earlier data. So These properties are not going to be used as a X in the input properties. All the things will be going for as the input properties, which I have done with the Pymatgen. So I'm going to remove all these things. So for that purpose, X is equal to data underscore featurize dot drop. And what columns are going to be dropped? These columns. Okay. Now, what would be your target property? My target property is the gap is direct or not. So this is my Y, my target property. So please copy and paste this code. Have you done this? Okay. Now we are moving about the for the covariance and the Pearson correlation coefficient. Okay. Sorry, this is the just a waste. Now, first of all, I'm going to calculate the covariance for all the uh, input properties with my output properties, like for every X value. Okay. It means for my all input columns, I am going to check what is the covariance value for this input property and our output property for each column, which are in the in my input property. Like I can see how many input columns are there. X dot shape. Okay. Oh, sorry. Shape does not have this. Okay. Now there is a 132 columns. Okay. So there would be the like 132 covariance factor which have to be calculated because all the 132 columns are going to be checked with the our target property. So now, so I first of all I have to calculate this covariance value. So for that, for column in X dot column, like there is a number of columns there. Covariance value is going to be calculated NP by using the NumPy uh, covariance formula in in what X column and Y. Okay, so 0 and 1. So it will start it from the 1, 2, 3. That's the thing. So this will going to be used for the calculation and the covariance column, and it is a covariance value. So there would be the values are going to be make a table. Now covariance underscore df, it means it will calculate all the values pt dot data frame covariance dot item which are to be saved here. They are make a data with the feature and it's a covariance value. Now covariance may be the positive or negative, so it is going to be contributed the same like but just it will be the negative way or it will be going to be contributed into the positive way. So I just calculated the absolute values for all the values here. Then what is the selected feature? Selected features would be all the feature which have the covariance value from a larger than a threshold value. What is the threshold value? Here I choose the threshold value is the 0.1. You can choose any value as a threshold like just about 0.2, 0.3, 0.4 just according to your work. Maybe if you have remembered about the work which is have done with the some metallic glasses related thing. here they choose the correlation threshold about covariance threshold about the point 3. Okay, so you can also choose according to you. I here just suppose choose the point 1. So all the features those have the minimum value which is small than this threshold value, they are going to be removed. Now all the X filter like I remove the some features. So these selected features are going to be my X filter. Like I make a X data set different, which have those only columns, which are have the threshold value, covariance threshold value larger than 0.1. Okay. So this is the shape like uh, how many how many input properties are there. Now I'm going to make a table like each for each property, and then I am also going to plot this bar plot with the property versus the covariance value. Okay. So now as I'm going to run this, uh, disconnected. Please copy this code and paste and run in your notebook. Now, if you see this image, there are only, sorry, there are only some features which have the value covariance correlation value greater than the 0.1. Okay, here you can see. Uh, or by using this see this plot, you can also decide what should be your covariance value. Just suppose I can also say like I have to include these features also in my input data, so I have to take these values also. So you can lower the your threshold value like just about 0.05, or you can also think like this like I don't have to include these values, so I am going to increase my threshold value of the 0.2. So these values also going to be eliminate. These are values also going to be eliminate. So you can choose according to that. Okay. Are you able to get same kind of plot? Anyone? Anyone of you? Is there anyone who is running the code or not? Ishwar, I think you are working or not, or you just stopped in
Yes,
between.
sir. Yes, sir. Yes, sir.
Have you got the output plot?
Oh, yes, sir. I have got it.
Okay. So now I want to see how many features are left. Okay. So if you see, I have also right here like this print remaining the features after applying the covariance threshold. So it is going to be print the remaining features which are saved here in the selected feature. Okay. So these are printed, and you can see there is a features which are left here. Magpie maximum number, Magpie range number, Magpie maximum atomic weight, Magpie range atomic weight, and Magpie range atomic weight and the mean atomic weight, average deviation atomic weight, and this GS volume, PA, melting temperature. So these all the properties are left. So I want to see how many features are there. So there is a chord because this is a array kind of thing. So I have to use here for the length. Okay. So the length of this selected feature is 18. So there are the 18 features are left as I use this threshold value. Okay. So 143 to sorry 130 133 to only just 18 features. So this is our filter method. So I filter the features by using some statistical parameters. Okay. Now I have left with the 18 features and I'm not satisfied with this. Like these 18 features is also the too large number. So for that purpose, what I can do, I'm again just suppose in the previous lectures we have used Pearson correlation coefficient very much. So I'm also going to use here. Like just suppose I'm going to make a heat map by using the features which are left in my data set. What's the 18 features? And I'm going to see how they are correlated to each other. So for that purpose, I have created a correlation matrix for which x underscore filtered. So what x I got after the removing the uh, features which does not have the covariance value below than 0.1. So those features are going to be calculated. Sorry, correlation matrices are calculated for those features. Now these are plotted as a heat map, and you can see. Uh, Please copy this code and run in your notebook, and you will get this heat map. And you can see here, as we earlier discussed in the some previous sessions, like if just suppose the Pearson correlation coefficient is about to 1, positive or negative, that does not matter. So those features are highly correlated. If your PCC value very close to 1. Okay. So here you can see there is these features have a very high correlation to each other. Like just it is giving to the PCC value 1. If you see here, it is about the 0.97. So they are also highly correlated. These two things is also highly correlated. These two things is also highly correlated. These two is also highly correlated. So what do you have to do? You have to remove just suppose these four features is highly correlated. So you have to take just one feature which can give the same information. Okay. So just suppose I have removed these features. So only this feature is also going to the same information. In among these two, you can also take one. In among these two, you can take one. So according to this, you can filter your features to a some narrow value. So three features is will be removed from here. One feature is removed here. One feature can be removed here. So five features. One also can be removed here. Six. One here from here like seven, sorry, three, four, and seven. Okay. Seven features can be removed here. So here I have see what are the features, and I remove. I take only in these four features. I choose only one. From this two, I choose one. I from this two, I choose one. From this two, I choose one, and from this two, I take one feature, and the same way I write this thing. You can also cross verify. Please copy this code and paste in your notebook and run this. So after removing the this after removing the features, I have just left with the 10 features. Okay. So now these 10 features, just suppose I will say I'm not satisfied these 10 features. I want to reduce more. Okay. So how can I reduce? So there is a wrapper method. So there is a message. So there is a wrapper method. What this wrapper method do? As I earlier discussed, it train the model on the different subsets of the features, and it selected in forward direction and increase the number of feature, and it eliminate the features in the backward direction. So for that purpose, we are going to use this method. So here I just choose a model which is the random forest classifier. So first of all, you have to choose a model to do this. Okay. So I have it choose here random classifier. So I take this model and I choose the some any estimator and the random state here. And then I run this RFP. This RFP is a like command for the wrapper method. Okay. Recursive forward selection and the reverse elimination. Sorry, recursive forward elimination. Okay. Then what is the estimator here? Which model I am going to train? Then number of feature which I want to select. Like you can give here a number like how many maximum features it will select. Just suppose you want to select just 5 features. So it will give you to the 5 features which are most correlated. Or you can also take 7 values. You can 6, 8, whatever you want. Okay. Then RFE dot fit, and it is going to be fit on the X and Y. Then selected features are going to be removed from here, and it will give you a list about those features which will be left. So here you can see the 8 features are left and 2 features are removed. Okay. Now, uh, I have do the lots of things into the features engineering. I have selected my 8 features, which have reduced from 133 to just 8 features. So now the next thing is it is about model training part. How you train your model by using the different algorithms and how you can uh, see the accuracy of your trained model. Like there is a k-fold cross validation of your model, and you can do the hyperparameter tuning of your model. So I have done all the things in the same code. If you see here, first of all, I have discussed these things very widely. First of all, you have to split your data. Train test splitting. Train data for the training of the model. Test data for the testing of your model. Now you can choose anything like point 2, point 3, point 4 according to your data, like how much data you want your in training part and how much data you want in your testing part. Okay. Okay. Just suppose before working on this, just suppose you want to visualize your data. Now, okay. So for this purpose, I have make uh, this distribution plot for each features, like for the eight features in the input and the 1 feature in the target. So here you can see these plots, like all the for all the features is the distribution. Okay. This is the distribution about the maximum atomic weight. This is the distribution about the mean atomic weight. This is the distribution about the mean melting temperature. This is about the maximum GS volume. And this is the space group number. And this is the range of the space group number. This is the mean space group number. And this is the average deviation of the space group number. This is the target variable. What is your y value? So here you can see it is converted into the 0 and 1. For true, it is 0. Sorry, for true, it is 1. And for false, it is 0. Now, in the model training part, first I have splitted my data into the 2 part, train and test. Then you have to scaling your data, standard scaler. So I am using here the standard scaler. You can also use min max scaler also, whatever you want according to your situation of the data. Then I have converted the data into the data frame just because after this it is give you the array kind of thing as you scale the data. So this is for just converting the data into the data frame. Okay. Now the models, how many models I'm going to use? Logistic regression, random forest, gradient boost, support vector classifier. What I have to do here, I take the estimate, oh, sorry. I am taking here it's the grid values. Just suppose properties, it's a hyperparameter tuning. Like for the estimator, it would be like 50, 100, 200, maximum depth would be the none, 10, 20. You can see what are the features for the particular algorithm and you can tune those. I'm just tuning here the 2 or 3 features because otherwise it will take a long of the time. It will not be completed into this session. So that's why I just choose here 2 and 3 features. Okay. You can also take the long range. You can make a learning rate very small, like 0.001, 0.001, and you can also increase your n estimators. So as your n estimator increase, it will the time is also going to be increased exponentially. Then I am going to take the k-fold cross validation for each model, and your results are going to be saved as a model name, its accuracy, its precision, its recall, and its F1 score. Okay. Now it is going to be calculated by using this. First of all, it is going to for the cross validation, then it is going to calculate it all the things, and this work on the extreme. Now these accuracy are going to be saved in their list. Now I'm running this code. So this is the complete code about the hyperparameter tuning and the cross validation. You can also make the separate code as we have also shown you in the earlier sessions. So that's up to you. Please copy this and run in your notebook. Surely it will take some time. You can use some other values also. Uh, as we do here, you can work this kind of thing with your uh, different data. Like just suppose I just take the perovskite data, you can take any other data which are available here. like this bootstrap Metis project and this ship train thermal conductivity. As I told, this is the website from where you can also download the data directly. Okay, and there is something Jarvis also. Jarvis is also a website from where you can download the data. So here you can find there is a different kind of data. Okay, you can download these and use for your work. These here you can also find some tutorials. Okay. Meanwhile, you can ask me question. Okay. You can see here you are getting the results. Uh, is about the model. What is the accuracy of that model? What is the precision of that model? And what is the recall values of that model? And what is the F1 score of the model? So this is my table, and I also plot the bar plot of this data by using the matplotlib to visualize how my features are increasing or the decreasing. Ishwar, have you got the output?
Yes, sir, I have got output.
Okay.
Logic, but I did not get any graphs. Just I have got a
No, no.
output of that.
Yeah. Now I'm going to share the code about the plot.
Okay, sir.
Please copy that and paste in your notebook. So please copy this code and paste in your notebook. If you see in this data, in this table, you can easily visualize like a gradient boosting and the support vector classifier outperformed among all the models. Like they are giving the approximately same values. Okay. For F1 score, for the recall, for the precision, and for the accuracy also. So they are outperforming models in this world. And after that, there is a logistic regression, which is also giving the good results after these two models. So this is the bar plot which we got. Here you can also compare among all the models. So here till now we have used the data which is available online to you. You can use that data. You can train your model. You can clean your data. You can do the your feature engineering on that data. You can also do the feature engineering manually. Okay. You are not just rely on these things like Matminer or kind of thing. But if you are using the Matminer, etc. things, you can boost your like uh, uh, you can do this featureization in just a few seconds, just importing the library and just apply that. Otherwise, if you do it manually, it will take a lots of time. You have to collect the data, then you have to do the average thing, then do that in the Excel or in the Python or in the Origin. So that is taking time. So there are other things also uh, by which you can do the featureization. Like there is a something O-link, then there is a flow. So there are the various things you can go for the literature and use those things also, not just a Matminer. There are the lots of things. Try those, compare those. Okay. They are using the different method. What method of the featureization is suitable for your work? As you see here, they have done the mean, median. Sorry, they have not used median. They have used the mean, average deviation, and mode, minimum value, maximum value, and the range. So they have these values. So maybe some other library is going to use a different thing. Okay. So you can check that. Okay, how that library is featureized my data. And according to you can according to your data, you can use any method. Okay. Otherwise, you can compare those. Then you have to find out like which featureization method is working good and why. Is there any question? Any one of you want to ask? No question regarding this work which we have shared with you today, like how you use this coding, etc. Matminer, Pymatgen. No. Okay. So in the next week, maybe there is a last session, and in the next week, maybe I will take the two sessions. Okay. One session is was cancelled in just second or third week, I think. So there will be some makeup session in the next week. So maybe I will try to take this session back to back in just one half an hour gap. So please manage the things according to that. If you want to join, or is there any suggestion like what we have to do in the next session? Like just suppose that we have the 4 hours in the next week.
Sir, means
Hmm?
now we are doing something models, right, sir? From starting onwards, if we do something else to prepare a model in a way we can understand, we can do like that, sir.
And uh, like which kind of model? Like just a random forest, etc., or you want to ask something else?
Something we can understand for doing further any models, sir. Further applications or further models we can do. For one, if we try one model from starting onwards, what? But we are not understanding the lines of the uh, what we want to type. That we don't know about that code, sir. That's why I think I am confusing like that way.
Okay, just if I'm
Whether
able to understand, you
I
want to
should
ask
want to learn
you,
Python. I am asking like that.
so you want to learn the Python.
Okay, sir. Because we
Uh,
that I'm not
I'm just
understanding
asking.
this very well that much.
Okay, Ishwar, for these
Sir.
things, like just suppose you are not able to understand why I'm using this line, why I'm using this, why I'm
Mm,
using this. Okay,
yes.
so for that purpose, I'm very frankly say I'm not able to give you all the things like in these sessions. Okay, it will take a lot of time because there are the lots of things behind this. So for these things, I'm just suggesting you you can go for the documentation of these libraries. Okay,
Okay.
go for the like sklearn. Just I'm show you. Just suppose you are want to learn about the sklearn. Okay, just go for the website of that. Okay, you can find here the cheat sheet. So what is the thing? How that work? Same for the plotting. Like so here you can see here is the some plotting classification. Okay, so here is the algorithm, gradient boost, nearest neighbor, random forest, logistic regression, and more. So I just want to see the examples. Okay, how they work. So they are working on the classification. So here they have given the like what are the classifiers are there. Like decision tree classifier, standard scaler is the for the scaling the data, pipeline to make a pipeline, MLP classifier, KNN classifier, Gaussian NB. So these are the models. So they have used this. So you have to see data many times, like the code many times, and then you see, oh, these things have to be right like this. Then it will work. Otherwise, it will not going to be work. So you have to see the data, see the code. Then you have to make your own code, write your code. Then you will find any error. Then sort out that error. Now you have the chat GPT. If you find you are getting any error, then copy and the paste in the chat GPT and find out why you are getting that error. Okay.
Okay, sir.
That is the best way, I think. In the this recent time, there is a you have to learn the coding, but at this time you have a something which will work for you.
Okay, sir.
Sometimes I may also use that because sometimes I'm just lost, like why I'm getting this error. So
Okay,
that
okay, sir.
takes a lot of time if you go for the manual, and sometimes it takes a lots of time to search a particular thing.
Okay, sir.
Okay. Go for the documentation and the chat GPT. If you want to do something like do some use some shortcut. Otherwise, there is a way. First, you have to learn the Python. Okay, learn Python from anywhere. Then go for the documentation. Then it will give you just like a uh, cheese butter thing. Like oh, I just import these things.
Okay,
It
sir.
is too easy if you have learned the Python.
Okay, sir.
Any other thing?
Sir, sir, nothing, sir. Next week, what you want to say, sir?
Ah, maybe I think we have the regular session on the Saturday. So I have to mail them when I can conduct the regular the session like just on the Saturday, or is there non-availability of the slot? So then I have to go for another day. Okay. Maybe I think you have the exam from the 2nd November.
Second, no. Sir, October 31st, we have got mail, sir. That's why I'm asking. And I want to know about that. Something mail on
Sorry?
a few days back, 1 month back, we have got mail on October 31st, Deepavali. There will be exam like that.
Okay. So I'm not aware about that actually. I'm just heard about like there is an exam in the 2nd November. I think in the some your that where you post your queries. I think I got the
Sir,
notification from
another
there.
thing, sir. Sir, the first two lectures of 33 and 32, some Kharagpur sir was said, no, sir. That was
Okay.
on molecular dynamics and DFT. It was not
Okay.
up to the marks because of that voice and some disturbance voice like that. It is occurring, sir. We are not up to the mark.
Actually, I'm
I
not.
think
I can't say anything about that. Actually, you have to post the query into the question answer thing. Okay.
I have also
You can.
posted, sir. But I am saying if you mention to sir, he will take another class of that two things. That's why I'm saying.
Okay. So they have to solve that issue. Actually, NPTEL team. Is there any other question?
No questions.
Okay.
Okay, sir.
Thanks. We are going to end this session. Uh, thank you so much. Bye bye. Good night.